In this video, we are going to look at how we go about running simulation of our design and show you an example of that. As you see right now, we are in the project mode of Vivado. We have our project open and we have the project manager pane selected. To run simulation, we're going to go over to the simulation under the flow navigator and click Run Simulation and choose Run Behavioral Simulation. This is going to elaborate our design and start up simulation mode. And you'll see here now that we are in simulation mode from this blue bar. And we could actually switch back and forth. We can click here to go back to our project manager or come back to simulation, and we won't lose any of our windows that we have open. So I'm going to walk through a little bit about how we use the simulator. There's a lot of different pieces here to understand. And so we're going to start by looking first on the left-hand side here. And so this is the Scope tab, and what it does, we're going to make it a bit bigger here. And it shows the different modules on our design. So in this module, I have one system Verilog module called For Functions, and that's the only one here. We also have global listed here. That's just the global library. It's not part of the design that we created. As you get further through the labs and you have more modules, you'll see them listed here. For whichever module we have selected, in this case For Functions, in the Objects pane here, we will see all of the different signals in the design listed. These include inputs, A, B, and C, outputs, and as well internal logic signals that we've declared. And finally, over here we have our waveform, which is really the most important part of the simulator. And you'll see right now we have, by default, when we create a new simulation, it will add all of these objects to our waveform. But it will only add the logic signals from our top level module. In later labs, when you have more modules, you may want to go in and select a different module and add in objects from lower in the hierarchy. But we're not going to look at that right now. So if we look at our waveform, right now we'll see that the waveform shows the values of signals over time. And right now we're at time 0, and we can see that the inputs have value Z, and Z means high impedance. Basically that we haven't actually set these input values yet, and so they're shown as Z. For all of the outputs and our internal signals, the simulator is showing them as value X, which means that they're unknown. And they're unknown right now basically because they are a function of our inputs, which we haven't set yet. And finally, you'll see that in simulation mode, we still have our tickle console down here that we're going to use in a minute. And so let me walk through some of the buttons you have. If you look up at the top here, that these buttons changed once we went into simulation mode. And so this button, Run, and you'll see a really small T next to it, it runs for a set amount of time, and you can choose the time using these inputs here. So right now it's set for run for 10. We're going to switch this to nanoseconds, and we're going to hit run here. And so you'll see our design here runs for 10 nanoseconds, and we are now, the yellow cursor is showing at 10,000 picoseconds, which is of course 10 nanoseconds. And the lines in our simulation window show the different values of our signals over this time. And so again, the inputs, since we haven't set them yet, still are going to have a Z value, a high impedance, and they'll be shown, and that's shown with blue. Whereas the other internal signals are shown, have the value X, and they're shown in red. So up here, we have other signals. The run basically runs forever, that you're probably not going to use that one, and you should always run for a set amount of time. And this button goes back and restarts it. Now, one thing you should notice is that when we ran for 10 nanoseconds, it also displayed the command down here in the tickle console. So we don't have to use the buttons at the top. We can manually type these commands into the tickle console if we like. So we're going to now go and reset the design back to time 0, and we'll use the restart button. And now you can see that the command for that at the bottom is called restart. Okay, so now we're going to look at how we can actually set the value of our inputs. And so we're going to go over to input A here and select it, and right click, and we're going to force a constant. And in the force value box, we're going to choose a constant 0. And then you'll see the next box is basically how long in the future do you want to issue this command. And most often we want to make it effective immediately, so we'll just be using 0 nanoseconds for this. And we hit OK. And it will set the value, and we won't see that take effect until we run for some amount of time. But you'll see the equivalent tickle command down here at the bottom. So we're going to set the input of B using the same method. And for the input C, I'm actually going to type in the tickle command, add force. And I don't actually have to give the full path name here. I can just say C. Since the 4functions module is our top level module, I can just use the name of its inputs directly. I don't need to give the radix here in hex since it's a 1-bit signal. It doesn't really matter. And so I can say we're going to assign C also to 0 and do that immediately. So now that I've set all 3 of the inputs, I'm going to go ahead and run for 10 nanoseconds. And now you'll see that we actually have some values over here, and for all of our signals now it's showing green. Green for good, meaning we actually know what the values of these signals are, and we are sitting here at time 10 nanoseconds after we've run that. But if you look at the scale here, we're actually only looking at the last few picoseconds, and that's because it's zoomed in really far. And so we're going to go ahead and use this button here for zoom fit, and that will zoom out so that we can see the full simulation from 0 nanoseconds to 10. And what you'll see here is that we have the inputs A, B, and C, all at value 0, and our outputs O1, O2, O3, and 4 have values 0, 0, 0, and 1. So now I'm going to change the input values, and so we're going to change B, and we're going to set B to be 1. And we're going to run for another 10 nanoseconds. And I'm going to go back and zoom fit. And so you'll now see here 20 nanoseconds of simulation has happened, and we've changed the value of B at this point, and we can click here and place the cursor here and see that it's at 10 nanoseconds. And we could go ahead if we like and change the value of C also to be 1. Run for another 10 nanoseconds, and we'll zoom fit. And so now we've tested 3 different values of the inputs. So before we go any further, I'm going to walk through a little bit more about using the waveform window and some things that you can do with it. So you already saw that we could zoom fit to see the entire simulation. And we can also use this zoom in button to zoom in and zoom out to zoom out. Or alternatively, we can click and drag to select some region and zoom in to that exactly. So we can, I'm going to go back out, we can click on a transition to place this yellow cursor at that point, and we can see what time that happens at. And there's also buttons here, this one, to move the cursor to time 0, or to move the cursor to the end of the simulation. And I'm going to zoom back out here. Once we place a cursor, we can use this button to center the cursor on the screen. Let's see, it seems to, there we go. And we can also, when we have one point and a signal selected, we can go ahead and jump back in time to the back and forward between transitions. Basically different points in time that the signals change. So you'll see that output 1 it goes back to time 0, and then the next changes at 10 nanoseconds. And then we're at the end of the simulation here. So that's also helpful to jump through different places where your signals change. Okay, so now that we've looked at the simulation window a little bit, we're going to look at how you can go and issue these commands and create a simulation in a bit more of an automated way, which you're going to want to do when you have larger designs. So now that we're familiar with the commands, we can actually combine these commands into a script file that we can run multiple commands at once. And so what we're going to do is we're going to go up to our File menu, and we're going to say File, Text Editor, New File. And it's going to ask us to name our file. And so I'm just going to call it sim4functions.tickle. And I actually already have one here from before. I'm going to replace it. Okay, so now I have a script, a tickle script file here, and where I can put in commands. So it's a good thing to always start off by restarting your simulation and setting time back to 0. Although that doesn't need to be done the first time, once you start changing things and rerunning, you'll be glad that the restart command comes first at the beginning. Then we're going to add our inputs. So I'm going to go back and I'm just going to copy in this from down here. And we're going to set our inputs like we did. I'm going to paste these. Now I'll add the run command. We'll change the value of A and run for 10 more nanoseconds. And so we can save. You can use Control S to save, or click the save thing here to save your file. And then what's nice about this is when we have this file open, we can right click anywhere here and we can select run. And basically what that is going to do is issue all of these commands into our tickle console down here. So it'll run them and we can go back to our waveform. We can zoom fit and see those here. So other things you might want to do once you've started this process is maybe you'll decide that you don't actually want to see all of these internal signals that Vivado adds, so you can always select them and delete them from your waveform. And if you ever want them back, you can always go back to your objects list and you can right click and add, or you can simply drag and drop over. When you're done running simulation, you can close simulation by hitting the X in the top right here. It'll ask you if you want to save this waveform here, and usually we don't need to. It'll always create a new one when we rerun simulation. You do want to make sure that you've saved your tickle function, as you can use that to rerun the simulation in the future. That's it for this video. You should have everything you need now in order to complete the lab and run simulation.